So in this hour, we will be understanding how to merge the datasets that we already extracted. And also we'll try our best to identify the important indicators or the variables which are available in these rounds for the calculation of multidimensional energy poverty. At the end, I will also try to estimate with the help of Professor Suman on, will already helped us in giving the course, so we'll estimate some of the understanding of his lectures. Okay. So, and I've already provided the the sample data, and then not even the sample, the original data of NSS, and the extracted data of NSS, and also the course with a do file. Okay. So, okay, starting with merging. First of all, we have to understand why merging is necessary. Even if in any data set you are working, why it is necessary, and what are the principle by which we should merge the data sets correctly. I'll start with these first, then I'll explain the philosophy of merging. So usually in all our data sets we have observation this side and variable on the vertical axis. All the variables are here and these are the observations. And if we want to add our different levels of data, levels means in any round of our survey provided by national sample survey, they classify into different levels based on maybe unique ID information, maybe based on individual information, maybe based on household information. They segregate the levels separately. Okay, so now there are two ways of merging. One is either we append or we merge. So this is how I mentioned. So if we have a data set as the master file, starting with the data in our STATA, another we wanted to add or merge. So if the variables are same, we only want to increase our cases, increase our observations. In that case, it will simply add the observations by their variable. It is simply called appending. And in whereas in the NSS survey and its rounds, they usually provide the labels with different variables, not necessarily the same variables. Okay. And observations are also different. Maybe one is submerged with another one, or maybe more, little more additional variables. Usually, one level, maybe level 2 we explained in the morning, level 2 is level 3. So level 2 is started with the household variables, whereas level 3 onwards are individual level variables. And this is how the structure followed in almost all the rounds of national sample survey. So when we are expecting more variables to be added to our master file, so we know that this is where more variables are available, so we want to take them together. So one of the principles by which we take them together is to merge it. So how to merge it? We must ensure that these portions or the observations must carry a unique ID in both the cases. If they have the unique ID, it will be easy to merge and correctly merge. So we have to track their unique ID, not just by the person. Unique ID are defined with so many indicators. Maybe they are district, maybe with their state. They have combined several indicators to define a unique ID to a person. Likewise, our Aadhaar card. Aadhaar card is a unique ID. So we will check those things first. Then we'll understand how to merge the datasets. Okay, so starting with any dataset we have shared already. So I have these. NSS 7/5. Then I will also give you the codes and the estimation of consumer expenditure round 22 and 24. So I may not be justifying in this class, but I'll be providing the logic behind the merging. So I have at this moment two files which are already extracted. Okay, so that I can able to merge them to combine them for a single file. So you can just see one is here label number. Okay, this is level number, but this is DCT file. I wanted DTA file. This is the combined DTA file. I think have I provided you the extracted .dta file in that folder? Not available there. Okay. So have you tried on your own to extract both the round level number 2 and level number 3? So next time you have. Okay. Then I think it will be easy for me to do the merging. So I will get my data. I think it is not there. I thought we'll do it in the class and save it. Given the time constant, we didn't do that at that moment. So I'll just do it here. And I'll tell you how to do this. So I did that already and kept it over here. I have my files, extracted files. Those can be extracted the way I suggested, 2, 3, etc. here in DTA format. So I'll just open one file now. Then I'll tell you the tricks of merging the second file. Okay, so I'm just importing the data from my folder. It's on. So it's on a household consumption on healthcare. So let me just open it. Okay, just give me a moment. It's here. Extracted file. So yes. So this is level number 2. I'm just going to open it. Level number 2. Now we have to carefully observe that level number 2 is carrying household information, whereas level number 3 is covering individual information. This is level number 3. Level number 3 has gender as a variable, age, then marital status, general education, then their principal activities, etc. Whereas level number 2 is of household type, religion, social groups, etc. So my purpose at this moment is to understand how these two separate DTA file, separate data files can be combined together, so that I may be able to analyze or find out some association of how many male and female are covered in this round from different religion groups or from social groups. Otherwise, it was of one file. I could have at best explain only one dimension, that is of either percentage of social groups. But now I have a, I have the options to analyze those together. These variables as well as the variables listed in the level number 2. So I have opened in the STATA, I have opened the file that is covering household information. Now to merge it, the standard suggestions given by the ministry about the variables, then in order to merge, you should have these information together. If you are carrying household variable, then you have to carry the unique ID till household variables, not beyond. If you are combining individual variable, then individual variables should be taken as a unique ID. Let me specify it. Till these byte space are covering, I have highlighted here. So till this FSU segment number, second stage stratum number, then household number. Household they have mentioned clearly about the household. So household number, if you combine these 4 variables together, you will get your household ID, household common ID. If we combine all together, including person serial number, you will get a person ID, person combined ID or unique ID. Now one is at the household level, another is at an individual level. How should I merge? My first logic for merging is that a household is actually split into individuals. So more the information I am going to get from the individual file. Hence, the merging command we require is very specific. So I have mentioned here in a slide. This is in fact the last slide so far as merging is concerned. So this is the one. You can just have a look. So merge one-to-one, there are 4 different ways of merging. One-to-one, one-to-m, many-to-one, or many-to-many. The last one, many-to-many, we usually don't suggest to merge because of, the master file is not carrying the common IDs of the second file correctly. There are just random, matching or merging of different individuals or cases. So first 2 are highly suggested, one-to-one or one-to-many. It depends on what file you have opened. So coming to our STATA command or STATA file which we have opened at the moment, or master file, the file which we have opened is level number 2. So level number 2 is carrying household information, and we need to define we need to define whether as per the instruction given by by the README file, through the README file, whether it is actually uniquely identified or not. These variables are uniquely identified or not. We need to check several times. So, so here the unique ID is FSU, SS, segment number, then second set stratum number, then household number. Okay. So the first command is to check whether we have those variables or not very clearly. These 3 and household number, FSU, segment, AAS, and household. Then if it is your individual file, then since we have opened the household file, we don't have the individual serial number at this moment. We have only our household serial number. Okay. So these are all available in the layout file. From there we extract it. So to check whether those together are carrying the value as an unique as a variable as uniquely identified or not. Is the first call to check whether they are uniquely identified or not. We usually operate through ISID as the command. So ISID, if you just click on fast variable, still it will say that yes. If you just operate based on one file or one variable, not combining as per the instruction, so it will only say that your file is not uniquely identified. Your variable is not uniquely identified. Hence, you have to take other variables together. Like, if from our Aadhaar number, just based on 2 or 3 number, through digit, we cannot identify the person. It might carry our district, code. It might carry our village code. It might carry our household code as well. So, just FSU is not uniquely identified. It says that variables FSU doesn't uniquely identify the observations. Let's check with ISID, FSU, then segment. It is still not uniquely identified. So I'll just phase out. So then I'll add the third. I'll check once again. It's working or not. It's still not working. So we'll just add the fourth one, that is household variable. Are you getting it correctly, or is there any trouble?
Sir, is this a clean data?
It's not that required even, because this is cleaning at this moment not required.
The variables which we have downloaded from the raw data, it's 40 variables are there. And here it is 26.
Oh, okay. I have taken. Okay. Somehow, some variables we have dropped it for our own purpose. No, to some extent we clean because of I'm going to use this data for other analysis. Otherwise, for merging is not required. Merging, you can simply mention FSU. You can divide the variables, all those common ID. I think it's given a common ID. They've not given in each of the round. They've not given the information through each of the variables. They only club together through common ID. So instead of at the type of extraction, you can actually take FSU separately. FSU, then replace segment, etc. You can take separately. Otherwise, substring command is substring is another command will be useful for extracting the individual variable. Okay. So if you are stuck somewhere, I think that can be addressed. Or I can also share this data directly with you right now. You can use it and explain. I think this one of the round I've already shared. One of these data set is shared. Or 1, 2, 3 is shared.
DCT files are there.
DCT files are not there. Not here. Okay. So, you want to check in your system at this moment? You can share. Even I can share. Or if you can note it down and it is understood, I think it's fine, right? Okay. So, so my purpose of mentioning for merging both of the data sets is to first of all identify how those common variables are uniquely identified. If they are not uniquely identified, we cannot able to merge. That's the standard principle. So I have now used these 4 FSU segment, replace and household as my uniquely identified variable. Where did I get it? I get it from the README file. Okay. So now I'll just check. Now there is no error displayed by STATA. So it says that your 4 variables can be carried together to define as a uniquely identified variable. Okay. These 4 variables I have actually generated a single variable GIAN is equal to these, and these are in string format. So you can just check they are all in string format. So it is here, all four. So I'm just going to show you another one I generated, that is household variable, HHID. Okay, so here is the HHID that is combining these 1, 2, 3, 4 variables. You can see this first is 5,000, 50,000, 50,000 is here. Then 1101, 1101, isn't it? So we created this combined variable, and these are combined, kept together because of the fact that they are the string variables. Had it been the variables with the type with non-string, those would have been with 50,003. They would have been converted to numeric values. It's no more 50,003. It is actually kept together. Fine. This is how the IDs are defined in case of the household file. Now I will show you another one. Another step to follow at this moment is to check whether this variable is not just uniquely identified. Also, you have to keep them chronologically. Okay, in increasing order. So you have to sort them and keep these variables. So our combined variable name is HHID at this moment because I've combined these four variables together. Okay, so I'll sort it. So otherwise I can check SID 1 second with HHID. All right. So it's uniquely identified. So I'll check. I have to also sort this HHID variable. Fine. So now that process is done. So far as my master file is concerned, the file which is open on the STATA page. Not required even, but it's better to keep one variable. If there are so many variables, simply generate GIAN HHID is equal to this. This is how we can generate. I think you know this, right? HHID is equal to this plus this FSU. FSU, then segment, this plus this plus this, and these four variables. So this will be generated. Fine. The next step is to sort it and then save this data set. Second one, in the second linking file, that is the second data set with us, which we are going to merge, is called linking file. But the linking file is carrying with individual information. So individual information, all let's open that and then discuss. I'll just open this first. Getting number, element group family. Element, present symptom number. This is level number 3. Level number 3 is individual file, carrying individual information, like starting from relation to head, person ID, then relation to head, gender, age, marital status, all sort of things. In my file, that is the level 3. I'm not finding that variable name is a segment. They are in we have actually taken it from here. Okay. So from the common ID, we have actually taken from the common ID. All those variables are common ID is actually from. Okay. Just give me a moment. So we have to take these from here. You can also try. Let me share this data set. Okay, FSU. It's not just the variable. You have to take the variable in your command at the time of extraction. 4 to 5th position, another five positions. So starting with 4, 5, 6, 7, 8. So 4, 5, 6, 7, 8 is your FSU variable. So where is it? It is available here. So yes, 4 to 8. Isn't it? So these variables should be at the time of extraction. If you understand carefully about this extraction procedure and also merging procedure, at the time of extraction you can take it. Otherwise, if you feel simply extract it using the concatenate command, substring command will help you to derive all these variables. There is a substring command. I will share with you, and directly if you put the value from FSU this to this, it will, you will get the variables at the later stage as well. Okay.
Sir, sometimes I think still, when we merge the files, it will show that the observation is not uniquely identified.
Yes.
In that case, we need to make
No. No, I'll show you. It will say here also that it's not uniquely identified.
So then we have to do the observation merging or like.
No. We should never merge by observation. Have I shared the sample question to you? Yes. Sample questions like this. Practice question. Yes, it is there. There? PDF one. It is downloaded, right? So these are with some MCQ, then some 2 marks type. Though we are not going to ask 2 marks type. So why I opened this, because I have carefully taken the snapshot of the estimations and kept for you to understand the logic behind the byte space, and also to understand how you can create a unique ID. Then also you can able to understand master file, then using file, etc. Okay, so we'll go through. I'm sure you can understand this correctly. Okay, so about your question, I'm just going to show you household file would also won't be also uniquely identified in some of the files.
When we merge the block, sometimes it comes like the observation is not
Uniquely identified, correct. I'll just show you. So this is part. This is our individual file, not the household file. Now this one, as per the suggestion given by the ministry to this database, they mentioned that your database, if it is individual in nature, you have to carry all those 5 indicators to define as your variable is uniquely identified. If you are only carrying till household file, just till household file, it's not going to be uniquely identified. So I'll just show you here. This is our individual file. Now I'm going to check ISID with this HHID. Okay, the HHID which is created. So this is not uniquely identified. This is what your question all about. Now we have to add other variables in order to prove that the variables we created is actually uniquely identified. So we have to add these two, level number and person serial number. So within a household, they have clearly defined whether household is is a unique family or it is a divided family. If it is a divided one, then what is the serial number of that person who is staying inside the family? Okay, so some classification they have very clearly mentioned. So if you are not stating it clearly to STATA, STATA is not going to read that correctly. So person serial number is here to be added. At least person serial number, we check level number can be added. If you avoid the level number which is given, still it is working. Okay, it's not creating any problem. But person ID number should be given at the time. So household number along with person ID number is your PID number. HHID plus person ID is your PID. I created PID. So ISID Then PID, if I check PID, I'm sure it is uniquely identified. Okay. And now two things are guaranteed. This data set, my PID as a variable is uniquely identified, but HHID is not the one, right? But in another household file, my HHID is uniquely identified. There was no question of PID because that is at the household level. You understand? I'll provide you this data also for you to work. Probably I forgot to give this. It's a big size data, you know. So even since the morning I was trying to send it took more time. Fine. So coming to this, okay. What is the logic of merging? This over there or that over this? That means this at this moment I have opened individual files. I can impose a household file on it so that household characters will be embedded on it. Otherwise, the reverse process can be followed. I'll open again the household file. Then I'll impose or include individual file. So both the approaches are fine. If I go by this, I know that these are the people where observations are more, and those are derived from the household. One household is actually divided into many individuals. So this is many kind of file. Previous one is one kind of file. One is split into many, right? So if I go by this approach to merge, the command should be m is to something, m is to 1. If I go by the reverse, it will be 1 is to m. If it is both the files are household level, then it will be 1 is to 1. If both are with household level indicator, there is no question of split of the members. The command would be 1 is to 1. If both the files are individual type, then again the command will be 1 is to 1. If both the files are household type, the command will be 1 is to 1. If one is household, another individual, or the reverse, then either it will be m is 1 is to m or m is to 1. That is the logic. Understood? Is there any problem?
So M is to 1 for which one? Like if we are merging household with the individual or individual
Individual to household.
individual to the household will be M is to 1.
M is to why?
Because many individuals are
Now my file is many types. So many first file is many types. So I have to start with m is to 1. The second linking file is 1. Is it okay? Or if I have opened the master file with the household characteristics, that will be 1 is to m.
Sir, you said the PID variable is created by summing this household ID plus
Plus person serial number.
why you miss the level number?
A level number should be given, but we check that level number probably in this round they probably have no values. Okay, so it is not required. Okay, so you can take it. There is no issue. It should be taken. Ideally, it should be taken as per the instruction to define. But we checked whether we are taking or not taking. Both are fine. Okay, so this is what I said from the beginning. You have to take as per the instruction. Okay, so what I'll do? Any other questions?
PID, when you are generating the PID, you are generating each level.
Each level, yes.
Point that to include the level in PID again, because as per the instruction, it should be household ID plus the personal ID.
No. Household ID plus level number plus person serial number. This is the instruction. This one. Household till this is household ID. Right? Then this is how we made the household ID. Then level number, that is covering 35, position number 35 and 36. 35 to two positions, 35 and 36. Okay. So what is this 35, 36? You can just check over here. 35 to 36. For your idea only. 35 to 36 is this one. Level. Is it okay? Everywhere now, from this round onwards, they have actually kept together. So from at the time of extraction only, you can mention this. These 4 variables are required. So no need to further decode or break that variable and derive those four indicators variable for you to define your common ID. Okay, so you could have done it from the beginning also. This is what I do. But some people use substring command to extract the variable they want. So I will provide that as well. Even in my video also I have mentioned this carefully. Okay, coming to the explanation again for this merging. Now at this moment it is the individual variable, individual file getting 5,55,352 observations. And there are 28 variables. After deleting some of the redundant variables which are not that useful for me, because I'm going to use this file for estimating some of the indexes or some of the estimates like headcount ratio, etc. Therefore, we didn't require. So at this moment, what I wanted to do, I have checked PID. I'll also sort this variable as well. Sort PID. That's the starting process because we need to keep them in order. So I have done this. I have to save. So now I'm going to merge. Merge. Okay. So otherwise, you just check this. Easiest way, just check data, combined data set, data, combined data set, merge to data set. Merge to data set. So the same principle, one to one or many to one, one to many or many to many or one to one by observation. So these last one, even last two one are not suggested. There are possibility of errors. So one to one, if both the files are of same nature, they are at the same nature, like if they both are individual file or both are household level file. Okay. So at this moment, those are of different nature. So I have opened the file. At this moment is individual type, so it is of many to one on key variables. Okay. So I have to specify which are the key variables. I've already defined the key variables. The common in both the case, which is the variable I'm taking. It is the HHID. Common is HHID. Now another catch. If you are taking your command as 1:m, 1:m, m is your second file. For m, you need not define your uniqueness of the ID. If it is 1:1, in both the files, uniqueness should be defined. That variable should be uniquely identified in both the files. For the m type of file, unique ID is not required. Unique ID is required, but may not be uniquely identified. Still, it works. We have just seen it. HHID is not uniquely identified. But the first one, m is to 1, one file where HHID is mentioned should be uniquely identified. Understood now? So we have already checked the previous file, that was the household file, has HHID and that was uniquely identified. So let's check. So I'll just take HHID over here.
M is to 1.
So HHID, then file. Which file name? File number 2. Another file which I wanted to merge. Now at this moment I have 28 variables, all are in string format. And observations are 5,55,000. So observation wise it's not going to increase because all the individuals are here only. We are just going to clock them, take those individuals by their household. So household profile will be added to the individuals. Got it? Hence, the observations which we have here, 5,55,352 is not going to be, observations are not going to be increasing. Variable will be more because we'll be adding household level variables. So block number, this is block number 3 I have opened. You can just check. So level 2 I'm going to add. Right? So I'll just submit. Yes. So number of variables now 45. One thing, To check again, you have to quickly cross check whether matching one is with higher number or not. Not necessarily, it is all 5,55,352 are matched in all the rounds, all the levels. Okay, so that is first step. Second is once it is merged, by default it creates a variable. It's underscore merge. So you know to merge, this is your now individual file merged with household file. So you have combined a file. Now what is the type of this file, combined file? What is the individual type or household type? It is now individual type because you are carrying individual information inside it. That means your new file should be uniquely identified with the individual variables, not the HHID. It should be with the individual variables. So at the PID level, it must be uniquely identified. Okay. So first step, since you are going to merge with other levels also, so you have to drop this merge file. That's the step. Drop this, right? Then for further check to merge another round, you can check with ISID, then with not HHID variable, it should be PID. It's uniquely identified. So I'm sure.
The PID is not uniquely identified in our system.
PID is not uniquely identified.
What is saying uniquely does not uniquely identify the
Okay, check the variables. Is it household level variables?
one is in household, another is in individual.
Right. You have opened this one, 75th round.
That's not generated.
Okay. Let me just do a trace. So I will just clear it and check the data which I provided to you, right? This is what you opened.
So that is working. Your data set is working.
Okay.
But if this kind of situation is coming,
Hmm.
here your PID is saying that PID is uniquely identified.
Okay.
Personal ID extra.
One of the rounds, I'm finding that is not uniquely
Yeah,
identified.
second state.
Are you please give me some clarity of which round you are talking about?
I'm talking about the
Consumer expenditure, right? Okay, okay. So for that, in some of the levels, even in my experience, in enterprise and ASUS data, I'll show you. Okay, okay, okay. I have this. Just give me a moment. ASUS round and or unorganized enterprise round, in consumer expenditure round. So they have taken on the rows, they have taken their activities. Even in time use survey also, they have taken all the activities in the row. But they are not the person, they are the activities. So for this, we need to take them to the column. Then only it will be uniquely identified. So I will provide. Long to wide. We have to resave that. So I'll provide that, then only it will be uniquely identified. It's little technical, it will take some time. Okay, so that is why I didn't tell this to the presentation at this moment. I will show you, I'll provide you that. With that command, the moment you enter with those variables, it will take to the column. Now, what are left is your observations only. So observation will be
level 5 onward in the consumer expenditure survey up to level 9. You have to reset those.
Reset. 5 to 9 needs to be reset. Understood? They have actually given by activities. So by activities, because they wanted to check the expenditure of the household by activities. So they somehow I don't know what is the logic behind keeping that way, but this is how they are forming it, and for us to define the uniqueness of the variables, we need to reset them. Okay, so I'll provide that code to you. Okay, so since we have already crossed 1416, so let me make it a little faster now. So Okay, so merging we have done. So merge, when I click this combining the data by this approach, you just saw that merge M1 with the unique ID, it is successfully merged. So we have got the data. Now we have to understand how other labels are going to be merged. We have to again check with the ISO of their unique variables. Then I think rest of the things are followed with the same process which I have just mentioned. Okay. So and good that you have asked. Actually, in some of the rounds we require reset. Is it fine? So let's proceed further about our indicators for energy related household energy indicators from the Indian data sources. So at this moment, we are specifying, since I'm explaining NSS data, so where we can get some of the energy related indicators, household energy indicators, we check with NFHS 75th health consumption round as well as consumption expenditure round. So I'll just show you, and we'll also clarify on our fifth day while explaining or computing energy poverty index. So we just check this with reference to the November 2012 indicators for the MEPI. So these are the one. Whether these are available or not, we just we actually helped for this, and then I found that only one indicator is more suitable from this round. Whereas we check the consumption expenditure, not the health round. So this is about household consumption expenditure. So we found this. So more variables except indoor pollutions are available. Okay. So I think it is more suitable for you to work with the consumption expenditure round to estimate the energy poverty index using NSS. Okay. So next one, like more on this, we'll address on fifth day in using NFHS data as well. So on NFHS data, I'll give you the background about NFHS data initially, about almost the latest 4th and 5th round. Also, I'll give you some anecdotal experience or citations of previous rounds. Then we'll calculate and estimate energy poverty. We'll also refer our own paper that is published. So now we so far over last almost 2 days, many concepts related to poverty were discussed by Professor Soman. So he has already discussed a bit about quantile functions, distribution functions, then generalized Lorentz curve, then Lorentz curve. Then also talked about in detail for poverty line. So we have added something of this. He has also discussed this, but we will calculate based on the estimations of through the Tendulkar committee and Rangarajan committee, and then we'll also calculate head count ratio, poverty gap measures, and square poverty gap measures using the same data set. And data set is already available with you. Okay, already here. So I'm just going to use this. So let's check once. And if you have any difficulties in between, I think I'm here to give you the result, and Suman is also here to give you the best interpretation of each of the indicators. Okay, so let's go for the data set. With the data set we have, and you can just check once.
ये तो हो गया अभी 1:1 है लेकिन दूसरे साथ उसके लिए PID कैलकुलेट कर
So this is the one we have already given. You can directly check the data.dta file is with you, and it is carrying almost all the information. We hardly dropped any information. Hence, our results are coming out to be good. We checked all the estimations, and here is the do file for each of the estimations, and Dr. Suman has provided this to us, and we utilize in the database to calculate this. Okay, so coming to this, here is that I have used the data set of this. I'll just tell you. Okay, I'll just open once again and operate from directly from this. So all right, so here is the data set. I think we have already changed to set the label. Okay, anyway, I'll also clarify, he has already labeled, but I'll just tell you here as well, using this data set. So first one, we'll check all the steps are given in the do file. I need not mention everything. So here is our monthly consumption expenditure variable number 219. Okay, so I'll just show you. I didn't get that much of time to label it. Variable number 219. It is E1 9. Yes, it is the one. Okay, it's on household monthly consumption expenditure. Okay, and another one is your household size. So if we divide these household expenditure with household size, we'll get the per capita. So per capita monthly expenditure is here. So that is why we have divided this and generated a as a proxy of our income. Okay.
Data you have just loaded, it was merged with the medical expenditure or consumption expenditure of different level already.
Okay. Yes. So okay, I'll tell you. This is the one we derived after merging the household information.
Okay.
This is already available in the household one.
Okay. Okay.
And household with the individual one, 2 and 3.
Okay. Okay.
Okay. So 2 and 3 is giving you the household size as well as the household members.
Okay.
More or less, we have got it from the household file itself because it has its household size is a variable. Okay, so the monthly MPC is already there, monthly household consumption expenditure, and also it is carrying the variable as the household size. Okay.
One thing, other level which are present there, so we have to, if we do with personal ID, so we have to match to 1:1, right? Other levels which are present.
Yes.
Okay.
Okay. If you are raising interest, let me just clarify. Just give me a moment. Yes, this is the schedule. Fourth one is household member. Till this we have done. Fourth means it is our level 3.
Yes.
Okay. So this is the one usually we don't require. Well, why particulars of former household members who died, who passed away during the last 365 days. So if we are interested in understanding the expenditure or even other indicators of health access, persons who are deceased are usually not required. So around 2000 plus sample who are missing from the data. And then if you're including, if your purpose is to understand the expenditure incurred due to funeral or due to other reasons, which are mentioned here, like whether hospitalized at least once during this period, and then the person is actually deceased. If that is actually required, you can keep. But for this, merging is not required. For this, append is required. Why append? If your 2, 3 is combined as one file, now these persons are new persons. These are not the same persons, okay? Completely new, and also adding new information. Fine. So if they are completely new, you are actually adding observations.
Yes.
They are not within the family. They are the separate persons who are deceased. Okay. So they are the family members who are deceased, but NSS actually carried a separate observations. Okay. You need to append. Append will be working.
And
If you are not using related to any info related to deceased person, better not to carry this in your merging.
and I think there are also expenditure on other levels. So we have to merge 1:1.
1:1. Further levels, it will be 1:1. Because you have created an individual file. Fine. So coming to this, so we will first of all understand. Okay, and open the data. Now some of the estimations we have provided using the do file. You can just check, create your. You can simultaneously operate and will interpret the result. And so this is what is highly required. And then before getting your MPC variable to be estimated and used, you need to distinct them. Okay, so through this now we have actually with the distinct command, we have distinct this to all these 3 important variables. We are using your MPC, we are using the household size, we are using the sector. Sector means rural or urban. 1 is a rural, 2 is urban. This moment, okay. So within sector there are two ports. So 1 is for rural, two for urban. Is it fine? So what I'm doing at this moment, I'm going to create the MPC file by dividing individual at the individual level. So what I do, we'll just created this. Then for better understanding, we are renaming this. Okay, so I think these have been renamed. Now, starting with the first requirement, so far as our earlier lectures are concerned, is quantile functions and how the MPC is actually presented through the quantile distribution function. So, using the analytical weight of these, so we created these and not running simultaneously. There might be a little bit of error because of the ending of the comments are not complete, so it might not work. I checked it's working, but let's do it this way. So I've done this first for the. So I already defined variable list required. Okay. All right, so it's working. Now we need to present into different subgroups by their income. So we'll just draw.
When we create like MPC, when we like creating a variable of MPC, in income there are outliers like. So how do we handle it? Like we have to drop it or we have to keep it?
Okay, for this, usually in my understanding, we use some transformation. maybe through if there are extreme outliers, we use. But I think for these data set, I cannot comment because we are getting the better result. But for very extreme result, we use some transformation, maybe log transformation, maybe normalization techniques. But here, our purpose is to identify the gaps. Okay, so gaps can be derived, I think, with this data set.
Like in household
If you have very high values, they will be above the formula anyways. For poverty analysis, it's not going to make much difference. Normally, normalize gap to zero. However, if you are doing inequality analysis, this may be a conflict. What you need to do is performance questions. You drop it and then re-estimate and see how things are changing, how the results are different. Yeah. Because for your inequality analysis, there could be coding error and there could be reporting error and so on. In those cases, you need to drop and revamp the analysis and see how it's.
So we need to go. Like the
You
maximum.
do both. You do both.
Both sides from the minimum or the maximum, the maximum value or the minimum value from both sides or.
What is the minimum value? The minimum value, the income can be negative. The consumption expenditure cannot be negative. Yeah. So if you have, say, very low consumption expenditure, look, it is ideally consumption expenditure should collect the consumption and consumption cannot be zero. Right? If you have zero value or if you have very reasonably small value, then you argue, look, it is impossible. A person cannot have that small consumption. For example, BMI. If you get a BMI of 70, you know it is going to be probably a coding error. It is not possible. Yeah. So in those cases, you may drop those values and see how things are changed. Yeah. So that's up to the researcher. I cannot give you a rule of thumb that it is wrong. That's something the researcher will justify.
So in that case, we have to see the standard deviation maybe less than the mean value. Like we see the maximum value, like for that thing, we check the standard deviation should be less than the mean or like the way.
Not necessarily.
I cannot do that.
Not necessarily. Standard deviation should be less than mean. I think that's not a standard, conditions where we will check the, outlier. Which there are different box, way by which outlier can be checked. So mean plus minus 1, 2 standard deviation. If standard deviation is much higher or less, I think it's not defining your outlier. So it's simply defining, the distribution.
For example, if you have delegates in your data set, what do you do? It's a real value. It's an outlier, but it's a real value. Okay. I mean, sometimes people draw. I mean, there is a completely separate literature when people try to estimate stop one person, which is not generally accounted for in data. But in general, if it's just one or two observations, that can give the entire results. Maybe you are dropping and trying and seeing how much give me your results. So when I accumulate, you definitely estimate the top. I would suggest recomputing this and see how is it. As a researcher, this is what you are supposed to do. Because forget about the comfort of the ideal world. It doesn't happen for researchers. We have to do a lot of dirty things in terms of data. Make sure what it is. Make to report that if I include this is my results of scheme, that's why I have a problem. Rather than trying to find a rule of thumb. I'm not sure what empirical is done. I'm not going to
True. So we need to check, several times with our data. So
Normal distribution.
Ideally, it should be, distribution should be to a large extent normal, but in reality, it is not normal. So at this moment, we are estimating the distribution. So for identifying some of the indicators which are explained in our theory, in our earlier lectures, we are just estimating this. So whenever we use any estimation for maybe for our regression analysis, that time by assumption you have to carry a distribution. So at this moment, our assumption is not there.
Yeah, I mean, if you talk about actual distribution, when we talk about normalization, we use that when we are using parametric estimation. There is a completely a big literature on non-parametric estimation. There is an empirical distribution. Empirical distribution may not follow any particular distribution. So whether you use Pareto, log normal, you are just making the assumptions, oh, my distributions closely resembles. But if you go in the non-parametric work, they do not make an assumption of parametric. They work with the distribution itself, however it looks like. So that idea of normality, then you are restricting yourself in that parametric work. If you want to do that, that's perfectly fine. But it is hardly, it's almost impossible that it will replicate exactly a particular smooth distribution. Just like the agent indifference curve. It doesn't exist. It exists on paper, that's fine. Same thing with distribution. You will never find a perfectly smooth log normal distribution. Doesn't happen. So as close, so you just show, okay, I draw that, I use this parameter with how closely it resembles my distribution. That's an assumption because.
Okay, so I think so. Rest of the estimations I will just try to derive. You can also try on your own, and if you have any difficulties, we can address it one by one. But given the time constraints, we have to go by this already. Okay, this is defined, so variable already defined. So, okay, in order to find out the GL curve and the Lorentz curve, you have to install. You have to install the this SSC install GL curve. Okay, so in some of your system it is not working, right? So and I think somewhere we have variable LPC already defined. Okay.
What is this local variable means?
Local is not a variable. Local means you are calling the name of the variable. Unless you run with the entire line together, that name will be forgotten. So what you are not doing, you are not creating something stored in the memory. But instead, if you define global, that means data remembers that name when you. Yeah.
So we, in that global, we call that global variable.
So global, if you define something, data remembers it. So every time you recall it, using a dollar sign, data will remember that. But if you local, it only runs or it only remembers that as long as you are running with them. Otherwise, data just doesn't remember that. After that, one line zero. Yeah.
Okay, so let's just try to run it. You will probably find. Okay, so here for the GL, I'm just simultaneously running these both the things together to check how this is working. For sector here it is 1 stands for rural and 2 stands for urban. Now this is our GL curve through the MPC and by sector.
Is it 0, 1 and 0, 1, right? It's on vertical axis, I cannot see from here. 0, 1, 0, 1, then it is the Lorentz curve.
This is the one. This is the okay. I think I have to make it big.
Yeah, there you go. This is the Lorentz curve.
Yeah. Yes, this is the Lorentz curve we have, and by sector, it's 2 for urban, and then 1 for rural.
So you can see kind of a dominance here. Rural, the rural inequality versus urban inequality. The rural inequality is strictly inside. From the data you could see, which is probably expected, or in urban area you have much higher variety of income. So it is shown from the data across India nationally that you have much larger. So here you do not have to use any particular input. Whatever inequality measure you use, you will see they will agree with the Lorentz ratio.
Communicative communicative frequency curve is above. Yesterday you told that if the curve is above, the communicative frequency curve.
Cumulative distribution. Okay. Yes, Pratap will draw that and you will see. This is inequality. Cumulative distribution function is about either related to probability or related to well-being. Lawrence, on the other hand, is just looking at inequality. Yeah, so Pratap will plot two other curves, we'll show you.
This is the one I think. Okay.
They will save somewhere, right? The graph will export somewhere, right? Yeah, let's run and see.
So at this moment, we'll just export it to a place. Download it is in. So I'll just give a path name here. Maybe to this folder. Give a path name of this folder. This path. Okay, so these are also give the path name. All right, so we will just operate the distribution function.
So this one, the first one, so what it did, it plotted both. So first the picture that came up, it plotted the distribution, and this one is the quantile. If you look at the last picture, so this is the quantile function.
Quantiles.
Yeah, so that means you have percentile of population on the horizontal axis, and then you have income on the vertical axis. Again, you see rural and urban. So you can see urban is the red one, right?
Red.
Urban, you can see urban is lying continuously above rural. Yeah, so this one is also showing that you have kind of now there could be, I don't know what is happening at the extreme left near zero. I do not know whether there is an intersect. It's really hard to say.
It seems to be, overlapping. Okay.
No,
This one.
not.
Red is above.
This one, right?
Yeah.
Red is above.
Does it?
It's
It's hard. So, of course, along with that, when you are working in real life, you have to compute the confidence interval around that. Yeah. So once you see, you will probably see for some part it may overlap. For some part, you will not be able to say later. But for other parts, it is definitely. Yeah. So for stochastic, you need to remember you have to say it is either greater than equal and strictly greater for some. And you can see for a large part, it is strictly above. So you could claim here that urban area, in terms of wealth, in terms of per capita expenditure, is dominating the rural area. Yeah.
Yes. Then in terms of okay, understanding for now in another 2-3 minutes we'll try to understand rest of the estimation the way we have already explained for defining the poverty line and examining the measures for headcount ratio, then for by urban or rural, then for poverty gap measure, then square poverty measures. So these are the two files were mentioned, but to some extent to calculate these Tendulkar committee suggestions, we have used 815 rupees 815 per capita as the MPC. I mean 815 per person per month for the rural and 1,000 for the urban as per the suggestions from the committees, and similarly for you can also estimate for Rangarajan committee estimate as well. So for that. We have mentioned this also pretty clearly here. 972 and 14007 for urban areas. Okay. So all the steps are given, but just one or two calculations I'll do this at this moment. Rest I think you can operate on your own. Steps are already given, and I'll just check. Then we'll mention. Okay, so in the place of head count ratio, we can also change this by mean, and I'll just check with the overall first, then we'll check with the mean value. Okay, so these are the estimations by rural and urban areas so far as Tendulkar committee suggestions is concerned, and some other estimations were made it for the rural area to check the poverty gap measure, and also to check square poverty gap measures similarly for by rural and urban areas, and rest of the things I think you can follow directly from the do files. Okay, so if you want, we need to interpret or estimate directly, can do that, but I think it's not that required. Anyone is having any difficulties here to operate this in your screen?
So the commands are not there. So, yeah.
No, I given only.
The updated commands are not there.
The updated ones are not.
No, it's 126 here, it's 110.
So
सेम तो आ रहा है
ठीक है ना?
is it working?
Yes, but
No?
it's working, but your commands
Till
are not there.
this?
Yeah.
Okay. So all the estimations are possible. Have you tried? So like all the indicators, even if so many other indicators, Professor Suman has already given. Some of the estimations we tried our best using the NFHS 75th round. But in my suggestions, by looking at the data, there are, as he rightly pointed out, there are huge extent of outliers. So though for poverty estimations or square poverty estimation, that is not that relevant. For inequality measures, etc., that is more relevant to check the distribution correctly. So you please try checking these results, and also try to interpret in a meaningful way. But my strong suggestion is to check with other theories that were also suggested. Okay, and more on this, if Professor Suman wants to give something. So is there any other things to be suggested that they will be working with the data?
Not much. I will work some part of it on first day that he did. Today you posting the exercise as well.
Yes, already posted. The answer key to be given.
Okay. So it is again based on the what we teach in this morning tutorials. Do we have any data exercises or
No, is it required to have anyone here requires data exercise? Having difficulty with or difficulty in operating data? Anyone really requires? We can extend help.
okay?
Otherwise, I think we should.
If no, that's fine. It's totally
It's already exceeded time.
So tomorrow morning, if you want, we can try to arrive a bit early. If you have any question, either on this data or on your exercise, we'll be happy to respond. And tomorrow we'll be starting with multidimensional methodology. We'll go a bit slow, not as fast as we did say yesterday. Yeah, it will be slow, so we'll have the conceptual issues tomorrow mainly, because they are involved, and then we slowly move to the main measure, mutations, and so on. Sounds good.
Right. So I think with this we need to stop.